In the last video, we built a model of the Celera 500L and successfully put it into operation. The small wings of the Celera in combination with the large fuselage, that means high air resistance and high weight, represent a real challenge for model making. To alleviate this problem, the wings and tailplane of the first model were disproportionately large, which made the task easier. In this video, all proportions are to be realized true to the original. To do this, the wings in particular have to be rebuilt. Since it has proven to be a good idea to cut the core out of styrator with a hot wire and then laminate it from the outside, this principle will be reused, as the airfoil S7055 is chosen arbitrarily. Compared to the first model, the profiles are so tiny. Care must be taken to ensure that the core is not completely cut through when cutting the grooves for the carbon rowings. The carbon tubes for insertion into the fuselage also don't have much clearance at the top and bottom. Overall, however, it is still easy to build the wings, including the ailerons. The wingspan is about 1,400 millimeters, which was also the original plan. The surface of the wings shall become more stable this time. In the last version, only the leading edge and trailing edge were laminated with carbon, and otherwise the foam core was visible, which caused a few cracks during the crash landing. For this reason, this version uses a layer of carbon fabric over the entire surface, 100 grams per square meter with warp threads. The threads will be visible later, but this is okay for us. Also, it turns out that the resulting surface is not completely flat because the vacuum appears to have compressed the soft styrator areas slightly. However, this should not stand in the way of our feasibility study. Next time, the vacuum would have to be reduced from 80% to perhaps 20%. Despite the additional lamination, the new wings are only about half as heavy as the old ones, simply due to their size. This is important because without weight reduction, the aircraft would fly very fast due to the smaller lift surface. According to FLZ Vortex, a weight reduction from 1440 grams to 1,000 grams would be required to stay below 40 kilometers per hour. The fuselage shall also be trimmed for lightness and must therefore be rebuilt. At least the old mold will be used again. The new wall contains one layer of thin glass fiber fabric with 86 grams per square meter and one layer of carbon, 160 grams per square meter. A second layer of carbon is only placed where the sandwich material used to be, as a reinforcement. The transition is barely visible afterwards. This time, no ribs are used as reinforcement, only carbon rowings. The expectation is that these will not break so easily in the event of a rough landing because they can bend elastically. The motor should also be lighter. The AT2312 from T-Motor will be used, which weighs only about 2/3 of the AT2321 from version 1 and has only half the power. Whether this is enough remains to be seen. In any case, the motor looks very small in relation to the fuselage. Including motor, the fuselage weighs 300 grams, just over half as much as the first model. The battery is also replaced by a lighter one, 228 grams versus 174 grams, still 4 cells. While painting the fuselage, it turns out that the surface is not completely smooth, probably because the polyester-based gel coat does not adhere well to the epoxy resin. But that's acceptable for now, next time better. Finally, new tail units are created. The elevator was previously enlarged, but according to FLZ Vortex, it can easily be the original size, as can the vertical stabilizer. Both are again designed as pendulum tail units, with carbon axles and external servo linkage. With that, the airplane is finished. Here you can also see the landing gear, which is now made of a bent wire that will hopefully absorb the vibrations during landing better than the previous carbon frame. Now it is getting serious again because the maiden flight is due. The pilot uses his experience and the suggestions of the spectators to adjust the control surface deflections. Finally, he is satisfied and announces that he is ready for takeoff. This time it flies straight away. The center of gravity is perfect, and only a little amount of trimming is required. The model is actually quite easy to fly, and all degrees of freedom can be controlled accurately. The developer also gets the opportunity to fly himself. It lies very stable in the air, possibly because the large and symmetrical fuselage provides some guidance. However, as with the first version, we notice that the nose pulls up at full throttle. Little power is required for straight and level flight, but the velocity can be increased significantly at high engine speed. The motor is more than adequately dimensioned. All in all, the aircraft is rather a fast one than a slow one, although it weighs only 1,060 grams. Overflights over the airfield are therefore comparatively brief. Unfortunately, there is no instrument available to measure the speed more precisely. Control from the ground is still very well possible. Loops and pirouettes are also feasible. However, the ailerons of the model are too small for very fast maneuvers. In curves, the rudder must be utilized to effectively initiate a turn and not just rotate around the roll axis. The rudder is quite large, as the ventral fin is also steered. Nevertheless, the influence is limited and easy to handle because the lever arm to the center of gravity is relatively small. Scaling to the small model is therefore possible without any problems in this case. As with the first version, landing is difficult because there are no flaps or air brakes in the model. When landing finally works, the advantage of the pliant undercarriage becomes apparent. Nothing ever breaks during several flights. There is surely room for improvement, for example, the precision of the canopy, retractable landing gears, and a 5-blade propeller. We only found a 5-blade propeller with 10 inches on the internet, which is clearly too large for this scale. So why not build the airplane larger so that it fits the propeller? Then a retractable undercarriage and other refinements would also be more feasible. This is the subject of our next project, in which a 3D printer will be used to help with the even bigger fuselage. Thanks for watching.